All right, second FRQ. This comes from 2003. This is the second question. An ideal spring tells us that all Hookean ideas work, all the simple harmonic motion stuff, if we have to deal with it, which we will, is hung from the ceiling, and a pan of mass m is suspended from the end of the spring, stretching it a distance d as shown above. That tells me we're probably going to have to deal with Hooke's law at some point. A piece of clay, also of mass m, is then dropped from a height h onto the pan and sticks to it. Express all algebraic answers in terms of the given quantities, that's capital M, D's, and H's, and fundamental constants. Determine the speed of the clay at the instant it hits the pan. Once again, we have an object dropping a height onto another object, so we're thinking UG equals K. Now something is dropping straight down, so it is translational. mgh equals 1/2 mv squared. Our mass is capital M. G, our height is capital H, equals 1/2 capital M v squared. M's go away. Our velocity ends up being square root of 2g capital H. Make sure you put the capital H in there. They might get a little fussy if you don't. Determine the speed of the pan just before the clay strikes it. Sorry, just after the clay strikes it. My bad. I got confused when I said before because that's not logical. All right, just after the clay strikes it. So strikes and collision are kind of the same word. The clay is hitting the pan. The pan's going to start moving. That is a momentum problem. So we have P of the clay initially plus P of the pan initially equals P total final. So we have capital M for the clay, the velocity is square root of 2gh, plus mass of the pan times the velocity of the pan initially, which is 0, equals m plus m, so it's 2m v final. The m's will cancel, so your v final is 1/2 root 2gh. I looked at the scoring guide, and that is an acceptable answer. If you ask me, I don't like there being two 2's there. So if you're going to put the 1/2 into the square root sign, it becomes 2gh over 2 squared is 4. So you end up with gh over 2. And I just think that looks better. I'm crazy. What do I know? Okay, determine the period of the simple harmonic motion that ensues. Your initial thought might be, well, if we have this collision right after it hits, it's already at equilibrium, so that must be the maximum velocity, and V max equals 2 pi a over t. That is true. We don't know the amplitude. So once we realize we don't have the amplitude, we got to go back to our bag of tricks, and on the equation card is the period of a spring, 2 pi square root of m over k. So the m, we know, is 2 capital M. We've got to figure out what k is. So like I said, we moved the distance d. Once we added the bar, we're going to have to figure out what k is. So let's go back up here and just think about that. It's in equilibrium at this point. So sum of all forces in the y direction equal, there's a weight force pointing down. And if we call down positive and up negative, we have a kx holding it up, which really we could write d for that, and it equals 0. The distance is d, so that's why the x became a d. So we add it over, mg equals kd, divided by d there. Our spring force, our spring constants are is equal to mg over d. Now in this case, it's just a single m, not the 2m. So let's put that back into our equation here. We got 2 pi over 2 capital M over, it was mg over d, capital M over g, mg over d. Those cancel. That d is going to pop all the way to the top. So our period is 2 pi times 2d over g. Gotta love it. I don't know why, but you do. All right, part D. Determine the distance the spring is stretched from its initial unstretched length at the moment the speed of the pan is a maximum, justify your answer. That means we have to give a proof. So you could just say, oh, it's blah, 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 but you have to tell them why. So this is another thing. Vmax is at equilibrium. We kind of said that once the mass hits the pan, it's at Vmax. So isn't it just a distance d? Well, we're adding mass to the pan. So the distance it's going to be at equilibrium is different. Well, using Hooke's law, F equals kx equals, let's be more specific. The force is mg minus kx equals 0 because we're looking for equilibrium. Let me write that. Vmax is at equilibrium. We've got to realize that now that we have the clay on there, this m is actually 2m times g, moving the kx over. Well, we know what k is. It's mg over d times x. Mg cancels. We have a 1 over d. I do not want to do that right now. Our x, our new equilibrium, is 2d. You got to remember that maximum velocity is at equilibrium, and since we added mass, we have a new equilibrium. Okay, E, the final part of this, and I know there's a big space here, but this goes with that down there. The clay is now removed from the pan, and the pan is returned to equilibrium at the end of the spring. A rubber ball, also of mass m, is dropped from a height h onto the pan, and after the collision is caught in midair before hitting anything else. So we are going to drop the object, and this time instead of sticking to it and adding to the mass remains the same. It just gets the new speed. I don't know. It's a little bit weird because it goes away, but we'll look at it. So the thing is, indicate whether below whether the period of the resulting simple harmonic motion, of the pan is greater than, less than, or the same as in part C. Well, if you remember from before with clay, our period was 2 pi square root, let's look at it so I'm not wrong, 2d over g. Like that. Well, the new one, which is going to be in orange, is equal to 2 pi square root of m over k. Well, now the m is just 1m. And our k, if you remember, was mg over d. So now that cancels, and now we have 2 pi square root of d over g. Well, that's less than. And if you do this math, then that is your justify your answer. You could also say the resulting mass is less, and period and mass have a directly, well, I mean, it's square rootedly, but there's still on top of the equation, proportional relationship. Meaning increase one, increase the other, decrease one, decrease the other. And that is the second question for today.